All right, folks, today we're going to talk about Pythagorean theorem. All right, so a few things before we get into this whole theorem, which is a super awesome theorem. But before we get into it, there are a few things we need to talk about. Okay, first off, this theorem only works with right triangles. So let's identify some parts of the right triangle. We've got two legs, right? And the legs are the sides of the triangle that are connected to the right angle. Okay, so the legs are always touching the right angle. Okay, now this other side over here that's not touching the right angle is called the hypotenuse. Okay, hypotenuse, spelled exactly how it sounds. Okay, so we've got two legs and a hypotenuse. Okay, on a right triangle. All right triangles have this. It's a very important thing to remember, all right? Okay, also, today we are on, we're in Unit 8. All right, we're on Lesson 6. Okay, so you can follow along in your workbook with that. All right, so we've got two legs and a hypotenuse. Now, let's look at this picture, okay? What do you see? Well, first of all, obviously it's a bunch of Legos. I love Legos, so we're using a picture of Legos. But also, inside the Legos, we have a right triangle. Okay? Now, let's try to figure something out here. How many, if we're using these Lego blocks as units, how many circles high is this triangle? It's 3 circles high. Okay? So we've got 3 right here. What's the bottom leg's length? 1, 2, 3. It's 4. So the bottom leg of the triangle is 4 units long. And then the hypotenuse is 5 units long. Now you're probably wondering, what's the deal with these big squares here, here, and here, all right? So the deal with those big squares, let's look at them. How many dots are in this square total? Well, if one of the side lengths is 3, there would be 9 dots in it total. Okay? How many dots are in the blue square total? Well, whatever 4 squared is, which is 16. And then 5 on this top square, how many dots are there? Well, it's 5 times 5. So we've got 25 dots up there. So 3 squared is 9, 4 squared is 16, 5 squared is 25. Now there's something really, kind of sounds like I'm just spitting a bunch of numbers here. And I am, no lies. But there's something interesting about here. If you take 9 and add the other leg squared length to it, 16, 9 plus 16, what does that equal? It equals 25. Huh. All right, so these lengths here being the lengths of the triangle squared. So this is kind of what the Pythagorean theorem means. All right, so let's say we've got our triangle. Okay, there we go. And let's say we've got, so we're labeling this, so the legs are always labeled A and B. A and B are always the legs. Let's make that look a little bit less like a 9 and more like an A. Okay, and the hypotenuse is always C. Now, just like up here, we have our leg length squared plus our leg length squared equals our hypotenuse length squared. Okay? So this is the same as 3 squared plus 4 squared is equal to 5 squared. All right. So down here, the actual theorem, the Pythagorean theorem, states that a squared plus b squared equals c squared. And if you haven't written this down, you're going to want to write it down somewhere where you will always see it because it comes up all the friggin' time. I'm not kidding. All the time comes up. Okay? Especially now that we've talked about it. All right, so let's apply this. Again, write this down. This is the magic theorem right here. Okay? So let's try it out. Let's put this thing to some use. Okay? So, let's say we've got a triangle and it's green because I love green. Green's the best. Okay? So this triangle, let's say it has a length of, oh, that was weird. Okay. Let's say it has one of the legs is 6 units long, the other leg is 8 units long, and then we don't know what this is. This is C, okay? In other words, it's just a big variable or question mark, okay? So we've got our hypotenuse of C, and we've got our 2 legs, okay? So Pythagorean theorem states, again, that a squared plus b squared equals c squared. So a being one of the legs and b being the other leg, okay? So let's test this out, all right? So if we do this, let's say we've got 6 squared plus, actually, I'm going to use a smaller pen for this. There we are. So we've got 6 squared plus 8 squared is equal to c squared, which is, again, this length squared. We don't know what it is, so we're not going to do anything with it, okay? So we understand 6 squared is 36, and 8 squared, 8 times 8 is 64. All right, somebody tell me, what is 36 plus 64 going to be? Oh my gosh, you totally got it right. It's 100. 36 plus 64 is 100, okay? Now, what number squared equals 100? Well, there's an easier way to figure this out. We can just do the square root, type it on our calculator, or you could understand that 10 times 10 is equal to 100. So the square root of 100 is 10, which means that C here is equal, or this side length is equal to 10. So our answer for this would be C equals 10, or the hypotenuse is equal to 10 units, okay? So see how we work through that? Okay, you're pretty much just substituting in the lengths for A and B and then solving this problem, okay? Now, there's another one we could do. I'll do another example. Oh, look, a triangle's already there. Okay, perfect. So let's say we'll do a bigger triangle this time. 5, 12, and let's say C. Great, because we don't know what C is, all right? So first off, write out a squared plus b squared equals c squared, right? Then we just fill things in. All right, so 5 squared plus 12 squared equals c squared, okay? So 5 squared is 25 plus 12 squared is 144. So that gives us, okay, 100 and 25 plus 44. All right, so we've got 169 is equal to c squared. Now, if you take the square root of that, you get 13. So here, C is equal to 13. That is the hypotenuse here. All right, and that is our answer. All right, folks, so that is how you use the Pythagorean theorem. We'll talk more about this next week. Make sure you are doing the homework check this week, okay? Because I do not have, it's due Sunday. You get 2 attempts, and I cannot have students retaking it, unfortunately. All right? So if you have any questions, feel free to drop by the office hours or email me. And hope you guys have a super rad weekend, all right? Have a good one.